When I was at school, I always loved maths and chemistry in particular, and physics actually, some bits of physics. And so I always knew I wanted to do something sciencey when I came to university. And both my parents are scientists and engineers, and so I think they really inspired me at home to enjoy those kind of things. And I loved the problem solving aspect. So when I started at university, I started studying natural sciences, and then I moved into chemical engineering from the second year because I realised that actually what I enjoyed the most was the application of the science and not just the science itself. So being able to solve the problems and find solutions for things that made an effect in real life. So I studied chemical engineering because it was the type of engineering that fitted best, because I enjoyed the chemistry as well. So I wanted to keep doing that, or an aspect of that, in my work. And then after I graduated, I actually had a year living out in Sweden when I didn't do any engineering, and I found that I really missed it. So then I decided I'd come back and do a PhD in chemical engineering, which was when I first came to Sheffield. And I did a PhD which looked at hydrogen as an alternative fuel for the future. And that really appealed to me because it had a real life application, and I could actually explain to people what I was doing. And then since then, my research has developed on from the hydrogen to look at how we do carbon dioxide utilisation. So to utilise any kind of carbon dioxide, you also need hydrogen. So there was a big connection in there. And I'm looking at different chemical, thermochemical, electrochemical processes of how we recycle carbon dioxide to turn it into fuel, to make it into a useful product. And I think one of the great things about that is I can actually explain to people, anybody I meet, what I'm doing and why I'm doing it and what the point is, because everybody understands that carbon dioxide is a problem in the atmosphere with global warming and greenhouse gases. And if actually we can take that carbon dioxide, recycle it, produce fuel from it, then when you burn that fuel, you make carbon dioxide again, so you produce a neutral cycle. And there's obviously lots of big advantages there. And in order to do it, you need quite a lot of energy. And so we're looking at how you harness renewable energy to then make this neutral carbon cycle. Since I became a senior lecturer just over a year ago, I've been working on a very large UK project for carbon dioxide utilisation, but also about 6 months ago I took on the faculty directorship for women in engineering. So we have a big programme of activities within the faculty to try and encourage more women into engineering. And our key goal is to be the first choice for women to both study and to work in engineering in the UK. So that's what we're aiming towards. So we do a lot of outreach work with primary school children and secondary school children to explain what engineering is, because there's a lot of myths out there that the engineer is the guy that comes and fixes the boiler when it breaks down, and actually engineering is so much more than that, and there's so much problem solving involved, so much real world application, so many interesting challenges in the world that can only be solved by engineers. And so we're trying to explain to school children, to parents, to teachers that that's what real engineering is, and how exciting that doing an engineering degree can actually be. And then we're also looking at how we get more female academics and more female researchers to come and work at the university, to provide excellent role models for our students that are here, and to encourage them to strive to be the best that they can be.